Have you ever noticed that every photograph you've ever seen of the Milky Way, that sweeping arc of light, that river of silver stretched across a dark sky, was taken from the outside? We've never left. No spacecraft has ever traveled far enough to turn around and photograph our own galaxies from a distance. Every image you've ever seen is an illustration, an artist's rendering, an educated guess built from math and inference, and the patient work of people who spent their lives trying to picture a home they could never step outside of. We have lived inside the Milky Way for 4.5 billion years, and we still don't know exactly what it looks like. Isn't that a strange thing to sit with? Hello, and welcome to Sleepy Science Stories. I'm glad you're here tonight. Maybe you're the kind of person who finds comfort in knowing that even the universe has unanswered questions. Maybe you're just tired and you wanted something larger than your own thoughts to drift into. Either way, there's nowhere you need to be right now. Let your body settle into wherever you are. Let your breathing slow. Let the day you just lived begin to loosen its hold. Because tonight, we're going to spend 100 quiet minutes inside the Milky Way. Not the version in the textbooks, not the tidy diagram with labeled arms and a neat central dot. The real one, strange, beautiful, still full of things we don't fully understand, and somehow more wonderful for it. 100 facts. Some will surprise you. Some will stay with you the way certain thoughts do, arriving quietly, settling in, still there when you wake. And if these slow journeys through the dark are the kind of thing that helps you rest, feel free to subscribe to the channel. It helps other curious, tired people find their way here too, one sleepy mind at a time. Now, take one more breath, let your eyes close if they want to, and let's begin. Fact 1. We have never seen our own face. Every map of the Milky Way you've ever seen was built from the inside. We have no observation point above the galaxy, no satellite far enough out, no photograph taken from a safe distance looking back. When astronomers draw that elegant spiral, two great arms curling outward from a glowing center, they are doing something closer to archaeology than photography. They are measuring the motion of stars, the density of gas, the pull of gravity in different directions. And from all of that data, they are inferring a shape they cannot directly see. It is, in a quiet way, one of the most honest things science has ever admitted. We live here. We have always lived here. And we are still carefully, slowly figuring out what here looks like. Fact 2. The four arms that weren't. For most of the 20th century, textbooks told us the Milky Way had 4 major spiral arms. It was a reasonable assumption. Many galaxies we observe from the outside have 4. Diagrams were drawn. The image settled into classrooms and documentaries, and the back of everyone's mind. Then, NASA's Spitzer Space Telescope mapped the galaxy in infrared, cutting through the dust that hides so much from us. What it found was quieter than expected. 2 dominant arms, Scutum Centaurus and Perseus, anchored to the ends of a central bar of stars. The other 2, demoted. Less structure, more suggestion. We had the wrong picture of our own home for decades, and no one knew because no one could step outside to check. It makes you wonder, quietly, what else we're still getting wrong. Fact 3. We live in the suburbs. Our solar system does not sit in one of those 2 great arms. We are in a smaller feature, a partial arm, a spur, called the Orion Arm. Not the main event, not the dramatic curving sweep of Scutum Centaurus with its dense star-forming regions and blazing young suns. We are in the quieter space between, on a minor offshoot, in what astronomers sometimes describe as the galactic suburbs. There is something almost comforting in that. Far enough from the chaos at the center to survive. Close enough to everything to belong. Unremarkable enough to be stable. We did not choose this location, but it may be exactly why we're here to notice it. Fact 4. The galaxy is bent. If you picture the Milky Way as a flat disk, like a coin, like a dinner plate, like every diagram you've ever seen, you'd be close, but not quite right. The outer edges of our galaxy are warped, twisted upward on one side, curving downward on the other like a vinyl record left too long in the sun. Astronomers believe this warping was caused by the slow gravitational pull of the Milky Way's two largest satellite galaxies. The large and small Magellanic Clouds tugging gently at the edges of our disk over billions of years. Even at the scale of 100,000 light-years, nothing escapes the pull of its neighbors. Everything bends, eventually, towards something else. Fact 5. You have never stopped moving. Right now, as you lie still, you are moving. Not just with Earth's rotation, though that carries you eastward at roughly 1,000 miles per hour depending on where you live. Not just with Earth's orbit around the Sun, though that adds another 67,000 miles per hour, but with the entire solar system, orbiting the galactic center at approximately 514,000 miles per hour. You have been moving at that speed since the moment you were born. You will be moving at that speed when you fall asleep tonight. Every dream you've ever had happened at 514,000 miles per hour. The stillness you feel right now is real, and it is also, in the deepest sense, borrowed. You are at rest inside something that has never stopped moving. Fact 6. Impossibly wide, surprisingly thin, the Milky Way stretches over 100,000 light-years from edge to edge. To feel that number rather than just hear it. If our entire solar system, from the Sun to the outermost edge of Neptune's orbit, were shrunk to the size of a single quarter, the Milky Way at that same scale would stretch wider than the continental United States. Everything you know about space exploration, every planet we've ever visited, every probe we've ever launched, all of it would fit inside a coin. And yet, at our location, the disk of the galaxy is only about 1,000 light-years thick, wide beyond imagining, thin as a whisper, a structure so flat relative to its width that a sheet of paper, by comparison, would seem like a canyon wall. Fact 7. Galaxy doesn't spin like a wheel. You might expect a galaxy to rotate the way a wheel does. Outer edges slower, inner regions faster, everything moving in a predictable gradient from center to rim. It doesn't. Stars in the Milky Way orbit the galactic center at roughly similar speeds regardless of how far out they are. Stars near the edge move almost as fast as stars much closer in. By the laws of physics that govern our solar system, this should be impossible. The outer stars should be moving far more slowly. The fact that they don't is one of the clearest pieces of evidence we have for dark matter. Something invisible, undetected, holding the galaxy together in ways we still can't fully explain. The Milky Way rotates like nothing we have a clean name for. It follows its own rules, quietly, out here in the dark. Spinning, everything spinning. Slower than it should be, faster than we expected, and somehow holding together. Fact 8. 1 cosmic year. The time it takes our solar system to complete one full orbit around the galactic center is approximately 225 to 250 million years. A unit of time astronomers call a galactic year or a cosmic year. Earth has completed roughly 18 to 20 of these orbits since it formed. 1 cosmic year ago, the Triassic period was just beginning. The first dinosaurs were finding their footing. The Atlantic Ocean did not yet exist. The continents were still fused into a single landmass. The sky above the same region of space where Earth now sits was filled with creatures that left no living descendants. That was 1 lap ago, 1 quiet loop around a center we've never seen. And here we are, somehow, on the next one. Fact 9. Who will be here next time if 1 cosmic year takes 225 million years? Then, the next time our solar system returns to this exact position in the galaxy, modern humans will almost certainly no longer exist. Not because of any catastrophe necessarily, simply because 225 million years is an almost incomprehensible span of biological time. Homo sapiens have existed for roughly 300,000 years. We are, by evolutionary standards, extraordinarily new. Whatever inherits this planet, or leaves it, in 225 million years will be as different from us as we are from the first fish that crawled onto land. Something will be here for the next lap. We just have no idea what it will be, or whether it will look up at the same stars and wonder the way we do tonight. Fact 10. The map we're still drawing as recently as 2024. Astronomers using data from the European Space Agency's Gaia spacecraft, which has mapped the precise positions and movements of nearly 2 billion stars, are still revising our picture of the Milky Way's structure. New features are being identified, old assumptions corrected. The exact number of spiral arms, the true shape of the central bar, the precise boundaries of where our galaxy ends and intergalactic space begins. All of it still being refined, still debated, still drawn and redrawn by people spending their lives on a question that may never be fully answered. We are mapmakers working from the inside, using starlight as our ink, drawing the outline of a place we have never been able to simply step back and look at, and somehow in that patient, humble, never-finished act of looking, there is something quietly magnificent. Fact 11. Something sleeps at the center. At the center of the Milky Way, roughly 26,000 light-years from where you are lying right now, something waits. It has no surface, no edge you could point to. It is a place where gravity has won so completely that even light moving at 186 cisson miles per second cannot escape. Astronomers call it Sagittarius A, pronounced Sagittarius A star, and it is our galaxy's supermassive black hole, 4 million times the mass of our Sun, compressed into a region smaller than the distance between Earth and the Sun. For now, it is quiet. It has not always been, and the galaxy carries the memory of when it wasn't. Fact 12. We watched stars orbit the invisible. For decades, a small team of astronomers at the Keck Observatory in Hawaii did something almost. They tracked individual stars near the galactic center. Stars moving so fast on orbits so tight that only something of extraordinary mass could be holding them in place. One star, called S2, completes a full orbit around Sagittarius A in just 16 years. At its closest approach, it travels at nearly 3% the speed of light, fast enough to circle Earth in under a second. For comparison, Our sun takes 225 million years to complete one orbit. We couldn't see what those stars were orbiting, but we could see the stars, and that was enough. Fact 13. A graveyard at the center Sagittarius A is not alone at the galactic center. Surrounding it, within just a few light years, astronomers believe there are thousands of stellar remnants, the collapsed cores of stars that burned out long ago. Neutron stars, white dwarfs, smaller black holes, each one the crushed remains of something that once burned. The region near the galactic center is, in a very real sense, a graveyard, densely packed with the dead weight of ancient stars, all circling the larger darkness at the middle. There is something still about the image, all that mass, all that history, orbiting quietly in the dark. Fact 14. Hidden behind 26,000 light-years of dust, we cannot see the galactic center with our eyes. Between us and Sagittarius A lies an almost impenetrable wall of gas and dust, molecular clouds so dense they block visible light entirely. If you pointed the most powerful optical telescope on Earth directly at the center of the Milky Way, you would see nothing but darkness and obscuring cloud. We can only observe the galactic center in wavelengths our eyes were never built to detect. Infrared light, X-rays, radio waves, translated into images we can see. The galactic center glows with activity invisible to every human who ever lived before the 20th century. For most of human history, the heart of our galaxy was completely hidden from us. It still is, in every way that counts. Fact 15. The galaxy's poor old heart. In 2022, using data from the Gaia spacecraft, astronomers identified something extraordinary at the Milky Way's core. A dense population of ancient stars, among the oldest in the entire galaxy, clustered at the very center, in a region they named, with quiet poetry, the poor old heart of the Milky Way. These stars formed in the galaxy's earliest years, when the universe itself was less than 1 billion years old. They are metal poor, meaning they formed before dying stars had seeded space with heavy elements. They are fossils, living records of what the galaxy was before it became what it is now. The oldest part of our home is at its center, and it has been there, burning slowly, since before Earth existed. Fact 16. The Fermi-N. Astronomers analyzing data from NASA's Fermi Gamma Ray Space Telescope made a discovery that no one had predicted and no one has fully explained since. Extending above and below the plane of the Milky Way, perpendicular to the galactic disk, like two enormous lobes of energy, are two vast structures now called the Fermi bubbles. Each one stretches roughly 25 zillion light-years from the galactic center. Together, they span half the visible diameter of the galaxy. They are enormous, they are energetic, and over a decade later, their origin remains genuinely uncertain. Some astronomers think they were caused by a past period of intense activity from Sagittarius A. Others think they were produced by a burst of star formation near the galactic center millions of years ago. What created them exactly? We still don't know. They simply hang there, above and below everything, enormous and unexplained. Above and below. Ancient energy, still expanding. Patient as everything else out here. Fact 17. When the giant woke Sagittarius is quiet now, but the evidence suggests it has not always been. Roughly 3.5 million years ago, recent in galactic terms, close enough that early humans were already walking the African savanna. Sagittarius A, appears to have experienced a massive outburst of energy. The event, called a Seyfert flare, would have sent a beam of radiation blazing outward from the galactic center, illuminating the Magellanic Stream, a ribbon of gas trailing behind our satellite galaxies. Like a searchlight sweeping across a dark room, early humans could not have seen it with their eyes. But the light from that event is still traveling, still moving outward through the galaxy while we sleep. Facteate stars that shouldn't exist near the galactic center in the harsh environment surrounding Sagittarius A. There is a cluster of young, massive, bright stars called the S cluster that have no business being there. The region near a supermassive black hole should be too violent, too disrupted by tidal forces and radiation for stars to form. The gravity near it would tear apart the gas clouds that normally collapse to birth new stars long before they could do so. And yet there they are, young stars, bright stars, stars that formed where stars should not be able to form. Astronomers call this the paradox of youth, and it remains one of the genuinely unsettled questions at the center of our galaxy. The rules say it shouldn't happen. The stars didn't listen. Fact 19. The mysterious threads. In 2023, astronomers using the Meerkat radio telescope in South Africa published images revealing something strange. Hanging near the galactic center, long, thin filaments of magnetized gas, stretching for up to 150 light-years, dangling in near-parallel lines like threads left behind by something vast that passed through. These structures had been hinted at for decades, but the new images showed them in unprecedented detail. Hundreds of them, organized, oriented perpendicular to the galactic plane, their origins still not understood. They don't fit neatly into any existing model. They are simply there, hanging in the dark near the center of everything silent, organized, and waiting to be explained. Fact 20. It smells like raspberries. In 2009, astronomers scanning a giant molecular cloud called Sagittarius B2, located near the galactic center, detected the presence of ethyl formate, a chemical compound responsible for two very specific aromas: raspberries and rum. This is real, peer-reviewed, published in the journal Astronomy and Astrophysics. The same cloud also contains vinyl alcohol, cyanide compounds, and enough ethanol, actual alcohol, to fill roughly 400 trillion pints. The galactic center is many things: violent, ancient, hidden, strange. But somewhere in all that darkness and gravity and mystery, if you could somehow breathe the air near the center of the Milky Way, it would smell, faintly, like a raspberry cocktail. The universe, it turns out, has a sense of humor. Fact 21. We are not the galaxy we used to be. The Milky Way you live inside tonight is not the galaxy that formed 13 billion years ago. It has been rebuilt, repeatedly. Over billions of years, smaller galaxies wandered too close, were caught by our gravity, and were slowly pulled apart. Their stars absorbed, their structures dissolved, their identities erased. What we call the Milky Way today is not a single thing that formed in one place and stayed. It is an accumulation, a long, patient act of consumption, still ongoing, that began before our sun existed and will continue long after it is gone. We think of home as something stable, something that was always here. But home, in this case, was built from the remains of others. Fact 22. Rivers of stars. If you could see the Milky Way from far above, which, as we discussed, we cannot, you would notice something that maps rarely show. Threading through and around the galaxy are long, thin streams of stars, not spiral arms, not clusters. Streams, rivers of individual stars, stretched into arcs that can span tens of thousands of light years, curving around the galaxy in paths that echo orbits long since disrupted. These are stellar streams, and each one is a ghost. Every stream marks the remains of something the Milky Way consumed. A dwarf galaxy or a globular cluster, pulled apart by tidal forces so gradually that its stars are still tracing the orbit of a home that no longer exists. They are epitaphs written in starlight, stretched across the sky in lines so faint they were invisible to us until recently. Fact 23. The galaxy being eaten. Right now, one of those destructions is happening at this very moment. The Sagittarius dwarf galaxy, a small, ancient galaxy that has been orbiting the Milky Way for billions of years, is currently being torn apart. With each pass through our galaxy's gravitational field, more of its stars are stripped away, stretched into a long stream that now arcs across a significant portion of our sky. Astronomers believe the Sagittarius dwarf has looped around our galaxy multiple times already, losing more of itself with each orbit. Some of its stars have already been fully absorbed into the Milky Way's disk. Others are still midstream, trailing behind what remains of their original galaxy, like the tail of something that has almost finished dissolving. It is a slow end, billions of years in the making, and it is still happening quietly tonight. Fact 24. The collision that made us 10 billion years ago, more than twice the age of Earth. The young Milky Way collided with a large dwarf galaxy. The collision was not brief. It was not clean. Over hundreds of millions of years, the two galaxies merged, their stars interweaving, their dark matter halos combining. The gravitational disruption of the event, sending shockwaves through both systems that fundamentally reshaped what the Milky Way would become. That ancient galaxy is now called Gaia Enceladus, named after the ESA spacecraft that revealed its existence and the giant of Greek mythology. Without that collision, our galaxy's thick disk, the dense, older layer of stars in which our solar system is embedded, might not exist in its current form. The merger didn't just add stars to the Milky Way, it changed the structure of everything already here. We are, in part, the product of a catastrophe that happened before Earth existed, and we carry its consequences in the very shape of our home. Fact 25. Stars that move against the current. Here is how you find the ghost of Gaia Enceladus today. Most stars in the Milky Way orbit the galactic center in the same direction. A vast, slow, coordinated flow that has persisted for billions of years. But scattered through our galaxy, there is a population of stars that move differently. They travel on elongated, highly eccentric orbits. Some of them move in the opposite direction, entirely retrograde, against the galactic current, like swimmers moving upstream in a river. These are the stars of Gaia Enceladus. Still here, still moving, but moving wrong by the Milky Way's standards, carrying in their orbits the memory of a trajectory set 10 billion years ago in a galaxy that no longer exists. They have been among our stars for longer than Earth has existed, and they have never quite fit in. Fact 26. The collision may have built the bar. The effects of the Gaia Enceladus merger may run even deeper than the halo of misfit stars it left behind. In 2024, A study published in the monthly notices of the Royal Astronomical Society proposed that the Milky Way's central bar, that dense, elongated structure of stars running through the galaxy's core, from which the spiral arms extend, may itself have been triggered by the Gaia-Enceladus collision. The gravitational disruption of the merger, the researchers suggested, may have been the event that caused the galaxy's inner stars to organize into the bar we see today. If true, it means the most central structure of our galaxy, the axis around which everything else is arranged, was shaped by a collision with something that no longer exists. The ghost didn't just pass through. It left its handwriting in the architecture. Built from collisions, shaped by what we consumed, still becoming. Fact 27. Shiva and Shakti. In March 2024, astronomers published a discovery that reached further back in galactic history than almost anything before it. Using data from the Gaia spacecraft, researchers at the Max Planck Institute for Astronomy identified two distinct structures of stars deep within the Milky Way's core, populations of ancient metal-poor stars moving in unusual coordinated orbits, unlike anything else in the galaxy. They named them Shiva and Shakti, after the Hindu cosmic forces whose union in mythology brought the universe into being. Each structure contains the mass of roughly 10 million suns. Their stars are 12 to 13 billion years old, nearly as old as the universe itself, and their properties suggest something remarkable: that Shiva and Shakti may be fragments of proto-galaxies that merged with the young Milky Way before it had even fully formed, the literal building blocks from which our galaxy was first assembled. We found the foundations, still there after 12 billion years, at the very center of everything. Fact 28. Stars born somewhere else. One of the quieter implications of all these mergers is this: some of the stars you see on a clear night were not born here. They formed in other galaxies, in Gaia Enceladus, in the Sagittarius dwarf, in proto-galactic fragments like Shiva and Shakti, lived parts of their lives in those systems, and were then absorbed into the Milky Way through collision and tidal disruption. They have been here so long that nothing in their current behavior marks them as foreign. They orbit like our stars. They age like our stars, but their chemical signatures, the precise mixes of elements forged in their cores, carry the fingerprint of where they were born, and that fingerprint tells a story of origins elsewhere. Some of the light falling on Earth tonight began its journey in a galaxy that no longer exists. Fact 29. The last major collision was more recent than we thought for years. Astronomers believed the Milky Way's last significant merger, the Gaia Enceladus event, happened between 8 and 11 billion years ago, and that our galaxy had been relatively quiet since. In 2022, new Gaia data complicated that picture. Analysis of star movements in the galactic halo revealed patterns described as wrinkles that could only persist if the stars that created them had joined the Milky Way far more recently. The wrinkles are too sharp, too distinct, too unworn by the passage of time to be 8 billion years old, the current estimate. The Milky Way's most recent significant merger may have occurred less than 3 billion years ago. We thought the quiet had lasted longer than it had. We thought we had been alone for longer than we had. It turns out the last collision was not that long ago, by galactic standards. Fact 30. What the streams remember. There is a stellar stream called the Orphan Stream, named because, for years after its discovery, astronomers could not identify which galaxy it came from. It had no parent, no origin. Just a long, curving river of stars arcing across the sky, untethered to anything known. Eventually, researchers linked it to a small, disrupted galaxy. But the name stayed, and perhaps it should, because every stellar stream is, in some sense, an orphan. Stars that belong to something that no longer exists, still following the ghost of an orbit set by a home that was taken from them billions of years ago. They don't know they are orphans. They simply move, as they always have, along a path that leads back to something that is no longer there. Fact 31. A number that resists the mind. There are somewhere between 100 and 400 billion stars in the Milky Way. Range 100 to 400 billion is not a sign of carelessness. It reflects the genuine difficulty of counting objects spread across 100 light-years of space, many of them hidden behind dust, many of them too dim to detect from our position, many of them in binary pairs that appear as one. The uncertainty itself is humbling. We can't count our own galaxy's stars the way you'd count items in a room. We estimate, we model, we do our best from the inside. But take even the lower number, 100 billion stars. If you counted one star per second, without stopping, without sleeping, it would take you over 3,000 years to reach 100 billion. You would have started counting in ancient Babylon. You would not be finished yet. Fact 32. The stars we never see, of all those hundreds of billions of stars, the vast majority are invisible to the naked eye, not because they're too far away, though distance is part of it, but because most stars in the Milky Way are red dwarfs. Small, cool, dim stars that burn their fuel so slowly and so quietly that even the nearest ones don't shine brightly enough for human eyes to detect without a telescope. Proxima Centauri, the closest star to our Sun, just 4.24 light-years away, is a red dwarf. It has been our nearest stellar neighbor for billions of years. It is close enough that on a cosmic scale, it is practically in our backyard, and on even the darkest, clearest night, you cannot see it. The night sky, you know, that scattering of bright points, is not the galaxy. It is the tiny fraction of the galaxy bright enough to announce itself to human eyes. The rest burns on in silence, unseen. Fact 33. Our Sun is not as average as we thought. For a long time, astronomers described our Sun as an average star. Unremarkable, middle of the road, nothing special. That description needs updating. Our Sun is brighter and more massive than roughly 85% of stars in the Milky Way. Most stars are red dwarfs, far smaller and dimmer. By that measure, our Sun is not average at all. It sits comfortably in the upper tier of galactic stars by luminosity. What we called average was actually, quietly, exceptional. This matters for more than pride. Larger, brighter stars burn faster and die younger, often before planets have time to develop complex life. The fact that our Sun is substantial enough to be warm and stable, but not so massive that it burned out in a few 100 million years, may be one of the less obvious reasons we exist. We live around a star that is better than average. We just didn't know it for a long time. Fact 34. Stars large enough to swallow worlds. The Sun feels enormous from where we stand. It contains 99.8% of all the mass in our solar system. 1 million Earths could fit inside it. And yet, by the standards of the Milky Way, our Sun is modest. The largest known stars, hypergiant stars like UY Scuti and Stephenson 218, are so vast that if placed at the center of our solar system, their surfaces would extend past the orbit of Saturn. Jupiter would be inside them. Every planet you learned the name of as a child would be swallowed without the star noticing. These stars burn so hot and so bright that they exhaust their fuel in millions of years rather than billions, blazing hard and dying young, leaving behind either nothing or a black hole depending on their mass. They are not long for this galaxy, but while they burn, nothing else in the sky comes close. The oldest light, still burning. Some stars in the Milky Way are nearly as old as the universe itself. In the galaxy's halo, the diffuse, ancient region surrounding the disk, there are stars whose ages have been measured at 13.6 billion years. The universe is estimated to be 13.8 billion years old. These stars formed when the cosmos was barely 200 million years old, in conditions so different from today that the galaxy they were born into would be unrecognizable. No heavy elements, no planetary systems as we understand them, no complex chemistry. They have been burning ever since, through the formation of our solar system, through the entire history of life on Earth, through every human civilization that has ever risen and fallen. They were old before Earth existed. They are still burning tonight, and if you know where to look, you can see them. Fact 36. A star is being born right now. Somewhere in the Milky Way at this exact moment, a star is being born. In dense molecular clouds scattered through the galaxy's spiral arms, regions of gas and dust so cold they approach absolute zero, gravity is doing what it has always done. It is pulling matter together, slowly at first, then faster, the cloud collapsing inward on itself, heating as it contracts, until the pressure and temperature at the core reach the threshold where hydrogen nuclei begin to fuse. Light appears where there was only darkness, the star that will replace our sun, the one that will be burning in a solar system we cannot imagine, around which planets we will never know might orbit, may already be forming somewhere in the galaxy tonight, gathering itself, slowly brightening, completely unaware of us as we are unaware of it, being born somewhere right now, as it has been every moment for 13 billion years. Fact 37. The galaxy is running out of fuel. Star formation in the Milky Way was once far more vigorous than it is today. In the galaxy's early years, billions of years before Earth formed, new stars were being born at a rate roughly 30 times higher than the current pace. The galaxy was rich in cold gas, the raw material of star formation, and it was using that material rapidly. Over time, that reservoir has been depleted. Stars have consumed it. Supernovae have heated it, making it harder for new stars to condense. The galaxy has aged. Today, the Milky Way forms new stars at a relatively sedate pace, perhaps a few solar masses worth of new stars per year. It is not dying, but it is no longer the furious star factory it once was. It is middle-aged by galactic standards, still creating, but more slowly now, more deliberately, the way most living things slow down with time. Fact 38. When a star dies, nothing is wasted. When a massive star exhausts its fuel and collapses, the explosion that follows, a supernova, releases more energy in a few seconds than our sun will emit over its entire 10 billion year lifetime. But the explosion is not the point. What matters is what it scatters. the elements forged in the star's core during millions of years of nuclear fusion. Carbon, oxygen, nitrogen, silicon, iron are flung outward into the surrounding space at thousands of miles per second, seeding the interstellar medium with the chemistry of future worlds. Those elements drift. They collect in molecular clouds. They collapse into new solar systems. Nothing a star ever was gets lost. It just changes form, scattered into the dark, waiting to become something else. Fact 39. Some stars will outlive the galaxy. The most massive stars burn out in millions of years. Our sun will last about 10 billion years total. It is roughly halfway through its life now. But red dwarfs are different. The smallest red dwarfs burn their fuel so slowly, so efficiently, that they are expected to remain on the main sequence for trillions of years, far longer than the current age of the universe. Some theoretical models suggest the longest-lived red dwarfs could burn for 10 trillion years. For context, the universe is 13.8 billion years old. 10 trillion is roughly 700 times that. When the last red dwarfs finally go out, the universe will be so old that the era we live in now, galaxies, stars, planets, life, will be an almost inconceivably brief opening chapter. Fact 40. You are made of a star that is gone. The atoms in your body were not always here. Every carbon atom in your DNA, every oxygen atom in your lungs, every iron atom in your blood was forged inside a star that no longer exists. That star lived its life, exhausted its fuel, and died in an explosion or a slow collapse, scattering its contents into space. Those contents drifted for millions of years, gathered into the cloud that eventually became our solar system, and found their way through a chain of events too long to trace into you. Right now, lying still, breathing slowly, you are the end product of a stellar life cycle that began billions of years before Earth existed. You are not just looking at the stars. You are what the stars became after they had time to think. Fact 41. Most of the Milky Way is missing. If you added up every star, every planet, every cloud of gas and dust in the Milky Way, you would account for only a fraction of the galaxy's total mass. The rest doesn't emit light, doesn't reflect it, doesn't absorb it. Every instrument we've ever built to observe the universe works by capturing electromagnetic radiation. And whatever makes up the bulk of our galaxy produces none. We call it dark matter. It accounts for roughly 85% of the Milky Way's mass. The stars, the gas, the light, everything you picture when you think of the galaxies is the small part. The visible is the exception. The dark is the rule. Fact 42. The galaxy would fly apart. Without its stars in the outer Milky Way are moving too fast. By the laws of gravity, stars that far from the galactic center should be moving slowly. The gravitational pull of visible matter alone isn't strong enough to keep them on their orbits. And yet they stay. They hold together. Something with enormous mass, distributed throughout and beyond the galaxy, is providing the extra pull needed. Remove dark matter, and the Milky Way's outer stars would gradually drift away into intergalactic space. The galaxy would dissolve, slowly, like smoke in a wind. Dark matter is not a mystery at the edges of physics. It is the reason the Milky Way exists as a single coherent thing tonight. Fact 43. We may have less than we thought. In January 2024, MIT physicists studying stars at the very outer rim of the Milky Way found something unexpected. Those stars were moving more slowly than the models predicted, suggesting the galaxy's gravitational core may be lighter than previously thought, with less dark matter concentrated at the center than decades of modeling had assumed. It was a quiet finding, published without fanfare, but it means our best map of the invisible. The architecture we've been building mathematically for 50 years may need to be redrawn. We are still learning the shape of the thing that holds us together, and it keeps surprising us. Fact 44, wrapped in darkness, the visible disk of the Milky Way is not the full extent of the galaxy. Surrounding it, extending far beyond the spiral arms in every direction, is a vast dark matter halo, roughly spherical, largely invisible, stretching outward for hundreds of thousands of light years, possibly twice the diameter of the visible galaxy, possibly more. The exact size is unknown because the exact nature of dark matter remains unknown. We live inside a galaxy that is itself inside something larger, a dark envelope we cannot see, cannot measure precisely, and cannot step outside of. The stars are not the whole story. They are a thin, bright layer wrapped in something much older and much darker. Fact 45. It is in this room with you. Dark matter is not somewhere distant in the far reaches of the galactic halo. It is here. The dark matter halo extends throughout the entire galaxy, including this region of the Orion Arm, including our solar system, including the space between the walls of the room you are in right now. Physicists estimate a density so thin it is almost nothing, and yet, multiplied across the volume of the galaxy, it outweighs all the stars combined. It is in the air around you. It is moving through the walls. It is passing through the space between your thoughts, silently, as it has every night of your life. Fact 46. Trillions of particles, every second if the leading theoretical models are correct. Dark matter is composed of particles, cold, slow-moving, weakly interacting with ordinary matter in almost every way. Almost. Physicists estimate that roughly 1 billion dark matter particles pass through every square inch of your body every second. They enter through one side and exit through the other without disturbing a single atom. No collision, no heat, no trace of any kind. You are, at this moment, being passed through continuously by something we have spent decades trying to detect and have never once directly caught. Passing through everything, touching nothing, holding it all together from the outside. Fact: decades of searching, nothing found. We have built some of the most sensitive detectors ever constructed, buried deep underground to shield them from interference, cooled to temperatures near absolute zero, monitored continuously for years, specifically to catch a single dark matter particle interacting with ordinary matter. So far, nothing. Not a confirmed detection, not a clear signal. The experiments continue. The detectors grow more sensitive, the searches expand, and the silence continues, which tells us something. Either dark matter particles interact even more weakly than we thought, or they behave in ways our current models don't predict. The most abundant substance in the galaxies has never once introduced itself. Fact 48. A web connecting everything zoomed far enough out. Beyond the Milky Way, beyond our local group of galaxies, beyond the nearest galaxy clusters. And dark matter reveals its largest structure. The universe is threaded with vast filaments of dark matter, forming a cosmic web, a three-dimensional lattice of invisible structure stretching across billions of light years. Galaxies form where these filaments intersect, pulled together by the gravitational density at the nodes of the web. The Milky Way sits at one such node embedded in a filament, connected to every other galaxy cluster in the observable universe by threads of something we cannot see. We are not floating freely in space. We are woven into a structure older than any star, larger than any map we've made. Fact 49. Dark energy pulls in the opposite direction. Dark matter pulls things together. But there is something else, something even less understood, that pushes them apart. Dark energy is the name we give to whatever is driving the accelerating expansion of the universe. Where dark matter is a gravitational glue, dark energy is a pressure pushing outward, causing galaxies to drift apart faster and faster as time goes on. It makes up roughly 68% of the total energy content of the universe. Together, dark matter and dark energy account for about 95% of everything that exists. The part of the universe we can see, touch, measure, and name, stars, planets, atoms, light, is the remaining 5%. We live in the footnote. Fact 50. The mystery that keeps us looking dark matter has been inferred from its gravitational effects for nearly a century. Since the 1930s, when astronomer Fritz Zwicky first noticed that galaxy clusters were moving too fast for their visible mass to explain. In all that time, we have not directly detected it. We have not identified what it is made of. We have not held it, photographed it, or built anything from it. We know it is there, the way you know a room is occupied by listening through the door, by the effects, not the thing itself, and yet its presence shapes everything. The structure of galaxies, the large-scale architecture of the universe, the reason the Milky Way exists in the form it does tonight. The deepest foundation of our home is something we have never seen, and we are still patiently looking. Fact 51. Thrown out. Not every star belongs to the galaxy it was born in. Some are ejected violently, permanently, flung outward from the galactic center at speeds of millions of miles per hour by the gravitational slingshot of close encounters near Sagittarius A. These are called hypervelocity stars, and they are moving fast enough to escape the Milky Way's gravitational pull entirely. They will not slow down. They will not return. They are crossing the boundary of the galaxy right now, entering the vast emptiness between galactic clusters, carrying with them the chemical signature of where they were born. A fingerprint of origin they will carry forever, long after the galaxy that made them has changed beyond recognition. Some things once thrown never find their way back. Fact 52. Traveling. With no destination. A hypervelocity star leaving the Milky Way is not heading anywhere in particular. There is no nearby galaxy close enough to catch it on any reasonable timescale. It is not in orbit around anything. It is simply moving outward into the intergalactic medium, into a darkness so complete and so empty that the distance between one hydrogen atom and the next can be measured in feet rather than fractions of an inch. It will travel that emptiness for billions of years, perhaps longer, and it will do so carrying light, still burning, still fusing hydrogen into helium, in a place where no other light exists for millions of light years in any direction. A star, alone in the dark between galaxies, still shining for no one. Fact 53. Worlds with no sun stars are not the only wanderers. Scattered through the Milky Way and through the spaces between galaxies are rogue planets. Worlds that orbit no star, warm no atmosphere, illuminate no moon. They drift in complete darkness, cold to temperatures near absolute zero on their surfaces, carrying whatever geology and chemistry they formed with, going nowhere in particular at no particular speed. Some were ejected from solar systems by gravitational interactions early in a system's formation. Others may have formed directly from collapsing gas clouds, never having orbited a star at all. Either way, they move alone through the galaxy, invisible to any telescope that relies on reflected starlight, detectable only by the faint gravitational distortions they create as they pass. Dark worlds, no sunrise, no sunset, just the endless moving dark. Fact 54. More rogue planets than stars. The number of rogue planets in the Milky Way may exceed the number of stars. Early estimates from gravitational microlensing surveys suggest there could be billions, possibly trillions, of free-floating planets drifting through the galaxy, far outnumbering the worlds we know about in stable solar systems. If accurate, it means the typical planet in the Milky Way is not a world like Earth, bathed in the light of a nearby star, warmed by a sun that rises and sets. The typical planet is alone, cold, moving through darkness so complete that the concept of a sky doesn't apply. Fact 55. A million stars in a sphere. Not everything that wanders is alone. Globular clusters are ancient, densely packed spheres of stars. Some containing hundreds of thousands, others over 1 million individual stars, all bound together by gravity and all are orbiting the Milky Way as a unit. We have identified over 150 of them circling our galaxy, moving in slow, elongated orbits that carry them far above and below the galactic plane. The stars inside a globular cluster are among the oldest in the galaxy, many over 12 billion years old, formed before the Milky Way's disk had taken shape. They have been orbiting together since before our sun existed, held in a gravitational embrace that has lasted longer than Earth has been, a loyal, ancient, still together. Fact 56. Some clusters arrived from elsewhere. Not all globular clusters were born in the Milky Way. Some, including the large cluster, Omega Centauri, the most massive globular cluster associated with our galaxy, are believed to be the strip cores of dwarf galaxies consumed long ago. What remains of those galaxies is not a stellar stream or a ghost orbit, but a tightly bound knot of stars, the nucleus of something that once existed intact, now orbiting a galaxy that absorbed everything else it had. Omega Centauri contains roughly 10 million stars and spans 150 light-years. It is so large and so unusual, with stars of multiple ages and chemical compositions, unlike typical globular clusters, that astronomers believe it is the heart of a galaxy that no longer exists. A galaxy reduced to its core, still orbiting, still holding together after everything else was taken. Halfway through 100 facts about the Milky Way. Halfway through 100 quiet things about the place you've always lived. If you're still awake, that's fine. If you're drifting, that's fine too. The galaxy will still be here when you come back to it. Take a breath. Let your body settle a little deeper. We have 50 more things to share and nowhere else to be. Fact 57. Stars that follow ghost orbits. Some stars in the Milky Way are moving in ways that no longer make sense for where they are. They follow orbits that were set billions of years ago in a galaxy or a region of a galaxy that has since been disrupted, absorbed, or fundamentally changed. They are still tracing the path of something that no longer exists, the way a spinning top continues to trace its circle after the hand that set it going has long since pulled away. Astronomers call these kinematically distinct populations. They are stars that belong, in a meaningful sense, to a different time, moving through the present Milky Way on trajectories inherited from a past that the rest of the galaxy has moved on from. The past is written in how things move, even when the thing that caused the motion is gone. Fact 58. The Orphan Stream. There is a river of stars in the Milky Way's halo called the Orphan Stream. It was named because, for years after its discovery, no one could identify which galaxy it came from. It had no clear parent, just a long, curving arc of stars moving together through the halo with no obvious source. Eventually, researchers linked it tentatively to a disrupted dwarf galaxy. But the name remained. Every stellar stream is an orphan in some sense. Stars still following the orbit of a home that was taken from them, tracing a path that leads back to something that no longer exists. They don't know where they came from. They simply move, as they always have, in a direction that used to mean something. There is something in that worth sitting with quietly. Fact: hypervelocity stars carry memories. As a hypervelocity star leaves the Milky Way, it carries something with it. Not physically. Nothing is attached to it. Nothing travels alongside it. But in its chemical composition, in the precise mixture of elements forged in its core, and in the cores of the stars that came before it, is a record, a fingerprint, the specific ratios of carbon to oxygen, of magnesium to iron, of element to element. These are determined by where and when a star forms, and they are essentially permanent. A hypervelocity star drifting through intergalactic space for 10 billion years will still carry in its spectrum the evidence of which part of which galaxy made it. It is the most permanent record we know of, a star that has left everything behind but cannot leave behind what it is made of. Fact 60. Nothing is truly lost. Of all the stars ejected from the Milky Way, all the planets drifting without suns, all the galaxies dissolved into streams and halos, none of it is actually gone. The mass remains. The energy remains. The chemical elements remain, drifting, yes, scattered, yes, but present. Conservation of mass and energy is one of the deepest laws in physics, and it holds at every scale. The stars that were flung outward are still burning. The planets drifting in darkness are still there. The galaxies consumed by the Milky Way are still here, in the motion of their stars, in the shape of our halo, in the orientation of our central bar. Nothing the galaxy has ever been has been erased. It has only been rearranged. Fact 61. The oldest thing in you, the hydrogen in your body, is ancient. Not old in the way mountains are old, or oceans, or even the earth itself. Ancient in a different category entirely. Formed in the first 3 minutes after the Big Bang, 13.8 billion years ago, when the universe was still too hot for atoms to exist, and matter itself was only just beginning to take shape. Those hydrogen atoms drifted through space for billions of years. They were gathered into stars, expelled in stellar winds, incorporated into gas clouds, collapsed into new stars, and eventually found their way into the molecular cloud that became our solar system, and then through a chain of events too long to trace, into you. The oldest thing in your body is older than every star you can see tonight. Fact 62. Your carbon came from a dying star. Our carbon is the backbone of life as we know it. the element around which every protein, every strand of DNA, every cell membrane in your body is organized. It was not here at the beginning. Carbon is forged in the cores of aging stars through a process called the triple alpha reaction. 3 helium nuclei fusing into 1 carbon nucleus under conditions of pressure and temperature that only exist deep inside a star. When that star exhausts its fuel and sheds its outer layers in a slow, luminous cloud called a planetary nebula, the carbon it made is released into space. Every carbon atom in your body passed through the death of a star before it passed through you. Fact 63. Your blood remembers a supernova. The iron in your blood was not made gently. Iron is forged in the final moments of a massive star's life, built up in the core as the star fuses progressively heavier elements, until iron accumulates faster than it can be consumed. At that point, fusion stops. The core collapses in less than a second. The resulting explosion, a supernova, releases more energy than our sun will produce in its entire lifetime, scattering iron and every other element outward at thousands of miles per second. That iron drifted through space. It gathered into a new solar system. It found its way into your blood. Every heartbeat you have ever felt was powered, in part, by the death of something enormous. Fact 64. Gold arrived. From a collision, not all elements were born in supernovae. The heaviest elements, gold, platinum, uranium, silver, require conditions even more extreme than a supernova can provide. They are forged in the collision of 2 neutron stars, the crushed, city-sized remnants of 2 dead massive stars spiraling toward each other over millions of years, until they finally merge in an event called a kilonova, releasing more energy in milliseconds than the sun produces in 10,000 years. The gold in any piece of jewelry you own arrived on Earth as debris from such a collision, scattered through space, gathered by gravity, incorporated into the early solar system, and eventually concentrated by geological processes into veins of metal in the Earth's crust. Every piece of gold that has ever existed was made in a moment of catastrophic beauty, billions of years before Earth formed. Fact 65. The oxygen you're breathing. Right now, the oxygen filling your lungs at this moment was exhaled by stars that no longer exist. Oxygen is produced in the cores of massive stars through nuclear fusion, carbon fusing with helium to produce oxygen nuclei, which accumulate over millions of years of stellar burning. When those stars die, that oxygen is released into space, mixed into molecular clouds, and eventually incorporated into new solar systems and planetary atmospheres. The Earth's oxygen-rich atmosphere, the one that makes animal life possible, the one you have been breathing your entire life without thinking about it, was built from the expelled contents of ancient stellar deaths, accumulated over billions of years of galactic chemistry. Right now, breathing slowly, you are inhaling the last breath of stars that burned out long before the Earth existed. Fact 66. A galaxy's patience. None of this happened quickly. The Milky Way has been running its chemistry experiment for over 13 billion years. Each generation of stars formed from the gas left behind by the previous one, slightly richer in heavy elements, slightly more complex, slightly more capable of producing the ingredients for worlds like ours. First-generation stars had almost no heavy elements. Second-generation stars had a little more. By the time our sun formed, 4.6 billion years ago, The galaxy had been enriching its gas for over 9 billion years. Our existence required that patience. Life as we know it could not have emerged in the galaxy's early years. There simply weren't enough heavy elements yet. We arrived at exactly the right time. Not by accident, perhaps, just by waiting long enough. 9 billion years of preparation. For this, for now, for you breathing slowly in the dark. Fact 67. You are continuously being renewed. The atoms in your body are not the atoms you were born with. Over the course of a lifetime, the cells of your body are continuously replaced. Old atoms released, new ones incorporated from food, water, and air. The carbon that forms your bones today was atmospheric carbon dioxide a few years ago. The iron in your blood is replaced over months. Even the neurons of your brain, which persist longer than most cells, are constantly exchanging atoms with the environment. You are not a fixed collection of matter. You are a pattern, a temporary, self-maintaining arrangement of atoms that the universe is passing through itself, like water through a shape made of water. Fact 68. Cosmic rays pass through you tonight. At this moment, high-energy particles, protons and atomic nuclei, accelerated to nearly the speed of light by supernova shockwaves, and other violent events across the galaxy, are raining down on Earth. Most are deflected by Earth's magnetic field or absorbed in the atmosphere. But some reach the surface, and some pass through you, through your skin, through your organs, through the soft matter of your brain, leaving a faint trail of ionization as they go. You will never feel them. They do no meaningful harm. But right now, lying still, you are being quietly touched by the most energetic processes in the Milky Way. Fact 69. The galaxy made complexity for most of the universe's history. Matter was simple: hydrogen, helium, a trace of lithium. These were the only elements that existed after the Big Bang. Everything else, every element on the periodic table heavier than lithium, was manufactured later inside stars through billions of years of nuclear processing and violent stellar death. The universe began simple and became complex. The Milky Way is one of the engines of that complexity, a system that has been taking simple things and building them into more intricate things for over 13 billion years. Atoms into molecules, molecules into dust, dust into planets, planets into life. You are not an accident at the edge of complexity. You are complexity itself, the current high-water mark of 13 billion years of the galaxy making things more interesting. Fact galaxy. Looking back at itself. Here is the strangest fact in this entire journey. The Milky Way, 100,000 light-years wide, 400 billion stars, 13 billion years old, does not know it exists. Stars fuse hydrogen. Black holes consume matter. Gas clouds collapse and scatter. None of it involves awareness. None of it involves knowing. Except here, in one quiet corner of one minor spiral arm on a small rocky planet around an unremarkable star, matter arranged itself into something that asks questions. Something that looks up at the galaxy and wonders what it is. Something that builds telescopes and writes equations and lies awake at night, thinking about things 26,000 light-years away. You are not a small thing in a large universe. You are the universe briefly, knowing itself, wondering about itself, lying still in the dark and feeling faintly the weight and the beauty of everything it is made of. Fact 71. The most magnetic thing we know, somewhere in the Milky Way, There are objects so magnetically intense that the term strong magnet becomes almost meaningless by comparison. Magnetars are neutron stars, the collapsed cores of massive dead stars, roughly the size of a city, with magnetic fields estimated to be a quadrillion times stronger than Earth's. A quadrillion is 1,000,000 billion. At that field strength, the magnetic force would be strong enough to affect the arrangement of atoms themselves from a distance of 100,000 miles. If a magnetar were placed where the moon sits, its magnetic field would erase every credit card, disrupt every electronic device, and alter the chemistry of your body from that distance. There are roughly 30 known magnetars in the Milky Way. They are, by any measure, the most violent, quiet things we know of. Fact 72. A bell still ringing. In 2004, a magnetar in our galaxy released a burst of energy in a fraction of a second that was more powerful than anything astronomers had ever recorded from beyond our solar system. The burst lasted about a tenth of a second. In that tenth of a second, SGR 1806-20 released more energy than our sun emits in 250,000 years. The burst was so intense that, despite originating roughly 50,000 light-years away, it measurably ionized Earth's upper atmosphere, physically affecting our planet from halfway across the galaxy. Instruments designed to study gamma rays went temporarily blind from the intensity. A tenth of a second, felt across 50,000 light-years. The galaxy rang like a bell, and we felt the vibration from here. Fact 73. Flashes from nowhere. Somewhere in the sky, roughly once a day on average, there is a flash. Fast radio bursts, FRBs, are millisecond pulses of radio energy so intense they briefly outshine entire galaxies. They arrive without warning. They last less than the blink of an eye. And in most cases, they are never repeated from the same location. Some have been traced to distant galaxies. A handful have originated within the Milky Way itself. Their cause is still debated. Magnetars are the leading candidate, but no single explanation fits all. Observed bursts cleanly. We detect roughly one per day. We understand fully none of them. Something in the universe is shouting in a language we haven't learned yet. Fact 74. Threads in the dark near the galactic center, hanging in near parallel lines like something vast left them behind, are hundreds of long, thin filaments of magnetized gas. Some stretch for 150 light-years. They are oriented perpendicular to the galactic plane, organized in a way that suggests structure rather than accident. Astronomers have known about a few of them since the 1980s. In 2023, using the Meerkat radio telescope in South Africa, researchers published images showing hundreds of them, far more than anyone had expected, arranged with an almost architectural regularity. What made them is still not known. They don't fit neatly into any existing model. They simply hang there, near the center of everything, organized and unexplained, like a question written in a language we haven't deciphered yet. Fact 75. Stars that breathe. Some stars in the Milky Way are not stable, variable stars, and there are many types. Change in brightness over regular or semi-regular periods, pulsating as their outer layers expand and contract in a cycle driven by the physics of their interiors. The most famous class, Cepheid variables, expand and contract with a precision so reliable that astronomers use them as cosmic distance markers. But the image that stays is simpler than the physics. A star, thousands of light-years away, slowly expanding, brightening, then contracting, dimming over days or weeks or months. Doing this not once, not twice, but continuously, for thousands of years. Breathing. Not metaphorically, just a star in the dark, expanding and contracting on its own quiet rhythm. Fact 76. The zone of avoidance. There is a region of the sky that astronomers call, with deliberate drama, the zone of avoidance. It is not dangerous. It is simply the part of the sky directly behind the plane of the Milky Way, where our own galaxy's dust and gas is so dense that it blocks our view of whatever lies beyond. Entire galaxy clusters, potentially hundreds of thousands of galaxies, are hidden behind the bulk of our own home. We know things are there. We can infer their presence from gravitational effects and the occasional radio or X-ray signal that punches through the obscuring material. But we cannot see them directly. Our own galaxy hides part of the universe from us. We live inside something large enough to have blind spots. Strange, yes, but strangeness is just wonder we haven't named yet. Fact 77. A radio portrait we just received. In early 2024, astronomers at the International Center for Radio Astronomy Research published the largest low-frequency radio image of the Milky Way ever assembled. Built from data collected by the GLEAM-X survey using telescopes in Western Australia, the image revealed the galaxy in radio wavelengths, colors invisible to human eyes, translated into a visual map. Hidden within it were star-forming regions never previously catalogued, the remnants of ancient stellar explosions invisible in optical light, and structural features in the interstellar medium that had never been observed before. It was, in a literal sense, a new picture of our home, one we had never seen before, assembled from light our eyes cannot detect. We have been living here for billions of years. We are still seeing it for the first time. Fact 78. The galaxy sings. The Milky Way is not silent, not in the way sound travels through air. Space is far too thin for that, but in the broader sense of electromagnetic emission, our galaxy is extraordinarily loud. It radiates in radio waves from spinning pulsars and cold hydrogen clouds. It glows in infrared from warm dust and young stars. It blazes in X-rays from matter falling into black holes. It flares in gamma rays from the most energetic events in the known universe. All of this is happening simultaneously, right now, across 100,000 light-years. If you could hear every wavelength the galaxy emits, if your ears could detect radio and X-ray and gamma radiation, the Milky Way would be deafening. It has never been quiet. We simply lack the instruments to hear it. Fact 79. The paradox of youth near the galactic center. In the harsh, radiation-soaked environment surrounding Sagittarius A, there exists a cluster of young, massive, brilliantly bright stars. They should not be there. The tidal forces near a supermassive black hole are powerful enough to tear apart the gas clouds that would normally collapse to form stars. The radiation environment is extreme. The gravitational disruptions are constant. Every physical argument says this is not a place where new stars should be able to form. And yet there they are, bright, burning, in a place where stars should not exist. Astronomers call this the paradox of youth. The universe, apparently, does not always check whether something is supposed to be possible before doing it. Fact 80. It smells like raspberries. In 2009, astronomers scanning a giant molecular cloud called Sagittarius B2 located near the galactic center, detected the presence of ethyl formate, a chemical compound responsible for two very specific aromas, raspberries and rum. This is peer-reviewed science, published in the journal Astronomy and Astrophysics. The same cloud also contains enough ethanol, actual alcohol, to fill hundreds of trillions of pints. It contains vinyl alcohol. It contains cyanide compounds. It is, chemically, a very complicated neighborhood, but somewhere in all that darkness and gravity and mystery, in the violent, radiation-soaked region near the center of our galaxy, if you could somehow breathe the air near Sagittarius B2, it would smell, faintly, like a raspberry cocktail. The universe has a great deal of dignity, and occasionally, absolutely none. Fact 81. Before the Earth existed, the Milky Way is 13.6 billion years old. Earth is 4.6 billion years old. That means our galaxy existed for 9 billion years before this planet formed. 9 billion years of stars being born and dying, of galaxies merging and being consumed, of dark matter halos assembling and dark energy pushing everything apart. All of it happening in a galaxy that had no Earth in it, no sun, no solar system of any kind in this region of space. For most of the Milky Way's history, there was no here for us to be from. The galaxy is not our story. We are a recent footnote in something that was already ancient before life existed anywhere on this planet. Fact test 82. The first stars had nothing. The very first stars in the Milky Way formed in conditions almost unimaginably different from today. They had no heavy elements. No carbon, no oxygen, no iron. None of the elements that make planets and life possible had yet been manufactured. Those first stars were made almost entirely of hydrogen and helium, the only elements that existed after the Big Bang. They burned hot and fast and died young, and in dying, they seeded the galaxy with the first traces of heavier elements. The first carbon, the first oxygen, the first iron ever to exist in this part of the universe. Every element heavier than helium in your body was made by a star that came after those first ones. We are not first generation. We are the product of many generations of stars learning, slowly, to make more complex things. Fact 83. A collision that changed everything 10 billion years ago. As we explored in an earlier chapter, the young Milky Way collided with Gaia Enceladus. But the full consequences of that collision run deeper than the halo of misfit stars it left behind. The merger dramatically increased the rate of star formation in our galaxy. The disruption of gas clouds triggering bursts of new stellar births that persisted for hundreds of millions of years afterward. It heated the galaxy's existing stellar disks, thickening it. It may have triggered the formation of the central bar. It restructured the Milky Way's architecture in ways we are still mapping today. A single event 10 billion years ago shaped the galaxy you live inside tonight. Everything has a before, even home. Fact 84. The galaxy has scars. Not all of the Milky Way's history was violent in the way collisions are violent. Some of it was slow, accumulative, the kind of change that happens so gradually that no single moment marks the before and after. The Milky Way's disk, the flat rotating layer of stars on Trace where we live, shows evidence of having been disturbed multiple times by the gravitational influence of passing satellite galaxies. Ripples in the stellar density, warps in the outer disk, streams of stars displaced slightly from the plane. These are not dramatic scars, they are subtle ones. the kind you only notice when you look carefully. The galaxy remembers its history in how its stars are distributed. Not loudly, just in the way things that have been through something carry themselves slightly differently afterward. Fact 85. The Sagittarius Dwarf has been here. The Sagittarius Dwarf galaxy, currently being absorbed by the Milky Way, has made this journey before. Astronomers believe it has looped around our galaxy multiple times over billions of years, losing stars with each pass, its structure progressively dissolving under the tidal forces of a much larger neighbor. Some research suggests that each passage of the Sagittarius Dwarf through the Milky Way's disk may have triggered a burst of star formation, including, possibly, the formation of stars in our own galactic neighborhood, around the time our solar system was assembling. If accurate, the solar system that contains Earth may have been nudged into existence, in part by the repeated gravitational disturbance of a galaxy that is still dying in our sky tonight. Fact 86. The most recent merger was not long ago. For years, the scientific consensus held that the Milky Way had been largely undisturbed for billions of years. That after the Gaia Enceladus merger 10 billion years ago, our galaxy had settled into a period of relative quiet. Recent Gaia data has revised that picture. Analysis of stellar motions in the galactic halo has revealed patterns, described as wrinkles or shells, that could only persist if the stars creating them had joined the Milky Way far more recently than previously thought. The current estimate places the Milky Way's most recent significant merger at less than 3 billion years ago. 3 billion years ago, the most complex life on Earth was still single-celled. We were not yet here to feel it. But the galaxy moved, and the evidence remains. 13 billion years of becoming, collisions and mergers and slow reforming, and still not finished. Fact 87. Our sun arrived at the right moment. Our sun formed 4.6 billion years ago. Not in the galaxy's youth, when heavy elements were scarce, and not in its old age, when star formation has slowed to a trickle. It formed at a particular moment in galactic history, when the interstellar medium had been enriched by enough generations of dying stars to contain the heavy elements needed for rocky planets and complex chemistry. But when the galaxy was still active enough to be forming sun-like stars at a meaningful rate. The timing was not guaranteed. Form too early and there isn't enough carbon. Form too late and the galaxy has quieted. Our sun arrived in a window, a narrow one by cosmic standards. And we are the result of that timing being exactly what it needed to be. Fact 88. 4 billion years from now, the Milky Way and the Andromeda Galaxy are currently approaching each other at roughly 70 miles per second. In approximately 4 billion years, they will begin to merge. The merger will not be a collision in any everyday sense. The distances between individual stars are so vast that almost no stars will physically collide, but the gravitational interaction will be profound. Both galaxies will be distorted, stretched into long tidal tails, their spiral structures disrupted. Over hundreds of millions of years, they will pass through each other, separate, fall back together, and gradually settle into a single, larger elliptical galaxy. A system astronomers have already named Milkomeda. Our solar system will likely survive, displaced to a different region of a galaxy that no longer looks like home. Everything we call the Milky Way is temporary. It always has been. Fact 89. The galaxy is aging. Star formation in the Milky Way is declining. The galaxy is consuming its reserves of cold gas, the raw material from which stars form. Faster than that gas is being replenished. The era of vigorous star formation, when the galaxy was young and bright and building itself rapidly, is in the past. What we have now is a slower, quieter galaxy, still forming stars, still evolving, but doing so at a pace that will continue to decrease over billions of years. Eventually, the last stars will form. The existing ones will age and die, and the Milky Way, like all galaxies, eventually will grow dark. Not soon, not in any time frame that touches the human world. But the galaxy has a lifespan, and we exist partway through it. In what may be, cosmically speaking, its long and gentle afternoon. Fact 90. We arrived at an extraordinary moment of all the times to exist in the Milky Way's 13.6 billion year history. We exist now, not in the furious early years when the galaxy was forming stars 30 times faster, not in the distant future when the last stars are cooling. Now, in a middle period when the galaxy is rich enough in heavy elements to support complex chemistry, stable enough to harbor long-lived solar systems, and still active enough that new stars continue to be born. Astronomers sometimes call this the era of stelliferous universe, the age of stars. It will last for perhaps another 1 trillion years before the last stars go out. We are near the beginning of it. We did not choose when to arrive, but the moment we arrived in is, by any measure, an extraordinary one. And here, in the middle of it all, you are lying still, breathing slowly, inside a galaxy that has been building toward this moment for 13 billion years. Fact 91. The luckiest address in the galaxy, our solar system, sits in a region astronomers call the galactic habitable zone, not too close to the galactic center where radiation is intense. Supernova explosions are frequent, and gravitational disruptions would destabilize planetary orbits. Not too far out in the sparse outer reaches where heavy elements are scarce, and the building blocks for rocky planets are thin. Here, in the middle distance, on a minor spur of a spiral arm, in a region that is, by galactic standards, remarkably quiet, conditions for complex life are as favorable as anywhere we know of. We did not choose this address. But of all the places in a galaxy containing hundreds of billions of stars, we ended up in one of the few that could support the asking of questions. Fact 92. We live inside a star. The space surrounding our solar system is not ordinary interstellar space. We live inside a structure called the local bubble, a cavity in the interstellar medium roughly 1,000 light-years across, where the density of gas is far lower than the galactic average. The bubble was carved by a series of supernova explosions that occurred over the past 10 to 20 million years, their shock waves pushing the surrounding gas outward and leaving behind a region of hot, thin, relatively clear space. We exist inside a wound the galaxy inflicted on itself long before we arrived. The explosions that cleared this space made it easier for sunlight to travel, for planetary systems to form without interference, for the quiet neighborhood we inhabit to be as quiet as it is. Fact 93. The galaxy touches you every day. Even in our quiet corner, the galaxy reaches us. Cosmic rays, high-energy protons, and atomic nuclei accelerated by supernova shock waves and other violent events across the Milky Way rain down on Earth continuously. Most are deflected by our magnetic field or absorbed in the upper atmosphere. But some reach the surface, some pass through buildings, some pass through you. Over your lifetime, cosmic rays from across the galaxy will have passed through your body thousands of times. They leave no lasting damage. They announce no arrival. They simply pass, carrying energy generated in events thousands of light years away, delivered quietly to a small planet in a quiet arm of an ordinary spiral galaxy. The galaxy has been touching you your entire life. You simply never noticed. Fact 94. A sky most Americans no longer see. On a truly dark night, far from any city, the Milky Way is visible to the naked eye, a broad, soft band of light arching across the sky, the combined glow of hundreds of billions of stars, too distant to resolve individually, but too numerous to be invisible. For most of human history, everyone saw it, every night, without trying. Today, roughly 80% of Americans live under skies too polluted with artificial light to see the Milky Way at all. The galaxy that shaped human mythology, navigation, agriculture, and spirituality across every culture in history has become invisible to most people. Alive today, not because it changed, but because we lit up the ground so brightly we can no longer see what's above it. The Milky Way is still there. We just stopped looking up. Fact 95. Every culture named it. Every human civilization that developed under dark skies gave the Milky Way a name. The ancient Greeks called it galaxias, the Milky One, from which our word galaxy derives. The Norse saw it as the path of the Bifrost Bridge. Indigenous Australian cultures mapped it as a river of the sky, navigating by its dark patches rather than its stars. The Navajo called it the backbone of the world. In Japan, it is the Silver River. In parts of Africa, it is the spine of the night. Different languages, different continents, different centuries, the same band of light above all of them. Every culture that looked up found something worth naming, something worth telling stories about, something that felt, in the dark, like it meant something. Fact 96. The first time you see it. People who see the Milky Way for the first time as adults, having grown up under light-polluted skies, often describe the experience in terms that go beyond simple surprise. Some describe feeling small in a way that is not frightening but clarifying. Some cry without fully understanding why. Some report a shift in perspective that persists for days, a recalibration of what feels large and what feels urgent, a quiet loosening of the things that had felt most pressing. Psychologists who study awe, the emotional response to encountering something vast and difficult to comprehend, have found that it reliably reduces self-focused anxiety, increases feelings of connection, and leaves people feeling, at least temporarily, more at peace. The Milky Way has been producing that effect in human beings for as long as there have been human beings to look up and feel it. Still there, above every city that's forgotten it, waiting without waiting for anyone who finds the dark. Fact 97. The galaxy is moving tonight. The Milky Way is not a static backdrop. Right now, as you lie still, the galaxy is rotating, slowly, on a timescale of hundreds of millions of years, but rotating nonetheless. New stars are forming in its molecular clouds. Old stars are evolving, some expanding into red giants, some collapsing into white dwarfs. The Sagittarius dwarf galaxy is losing more of itself to our tidal forces. Hypervelocity stars are crossing the boundary into intergalactic space. The Fermi bubbles are expanding. The stellar streams are stretching. Somewhere in the galaxy, A star that has never been named is dying tonight, its outer layers expanding into space, seeding the interstellar medium with the elements of future worlds. The galaxy does not pause, not for sleep, not for anything. It simply continues, as it has for 13 billion years, doing what it does. Fact 98. Everything you know happened here. Of all the facts in this journey, this one is the simplest. Every person you have ever loved was born inside this galaxy. Every place you have ever been is inside this galaxy. Every book ever written, every piece of music ever composed, every war ever fought, every kindness ever offered. All of it happened within the boundaries of one spiral, galaxy, 100,000 light-years wide, in an unremarkable region of an unremarkable supercluster, in a universe containing at least 2 trillion other galaxies. Everything, every moment of every life that has ever been lived on this planet, all of it happened here, in this one quiet place. In the galaxy, you have been living inside your entire life without ever quite thinking of it that way. Fact 99. The Milky Way will outlast everything we build. In 4 billion years, the Milky Way will begin merging with Andromeda. In trillions of years, the last stars will cool. But on the timescale of human civilization, even the longest, most optimistic projection, the Milky Way will continue to exist essentially unchanged. Every monument ever built will be gone. Every language ever spoken will be forgotten. Every record of every human achievement will have dissolved back into the matter it was made from. And the galaxy will still be here, rotating, evolving, carrying the stellar streams and dark matter halothos and ancient globular clusters it carries tonight. It does not need us to persist. It was here before us, it will be hereafter. And somehow, knowing that is not sad. It is, quietly, one of the most comforting things there is. Fact 100. And yet, for this moment, the Milky Way is 13.6 billion years old. It contains up to 400 billion stars. It has survived collisions with other galaxies, the formation and death of generations of suns, and the slow consumption of everything that wandered too close. It does not know you are here, and yet, you know it is there. You in this quiet room, in this one brief life, on this small planet in an unremarkable arm of an ordinary spiral galaxy. You looked up, you wondered. You spent 100 minutes drifting through something larger than any word for large. Of all the matter in the Milky Way, all the gas, all the dust, all the dark, only the tiniest fraction ever becomes something that can lie still in the dark and feel the weight of what it is part of. You are that fraction. And for this one moment, fleeting, impossible, unrepeatable, the galaxy is not just something above you. It is something you are inside of. Something you are made of, something, briefly, that knows itself through you. And now the light is fading, the way it does at the edge of sleep. Not all at once, but gently, one thing at a time. We've drifted through 100 quiet truths. From a galaxy we've never seen from the outside, to the sleeping giant at its center. From the ghosts of consumed galaxies to the stars that breathe alone in the dark. From the invisible architecture holding everything together to the ancient collisions that made us what we are. And somewhere in all of it, in the stellar streams and the magnetar fields, in the raspberry-scented clouds near the galactic center, in the slow, patient chemistry of 13 billion years, there was you, breathing slowly, thoughts softening, maybe already more asleep than awake. You are not a visitor to the Milky Way. You are not an observer, looking in from the outside. You are made of it, assembled from hydrogen older than any star you can see, from carbon that passed through the death of a sun, from iron forged in an explosion so vast it scattered the building blocks of blood across light years of space. The galaxy did not make you by accident. It made you the way it makes everything, slowly, patiently, across unimaginable time, through fire and collapse and drift and renewal, until matter arranged itself into something that could lie still in the dark and wonder where it came from. You are the Milky Way, briefly conscious. A small warmth in a quiet corner, resting in the arm of a spiral that has been turning since before the Earth was born. So wherever you are right now, whether still awake or drifting beyond the edge of thought, may your dreams tonight be gentle. May your body rest like starlight on still water. May you carry with you, even faintly, the memory of a galaxy that glows not just above you, but within you. If you'd like to continue exploring, the next journey is waiting whenever you're ready. And if these quiet nights help you rest, consider subscribing. It helps others find their way here too. The Milky Way will be there tomorrow. Good night.